Okay, so we've got our last two examples that we're going to look at in the section on the binomial theorem. And like I said, these are going to be like definite test level questions because these require some thought. So they're somewhat similar to the last two examples that we looked at in class. But what makes these more difficult is when you look at your binomial, both terms in the binomial have some factor of x in them. Okay, so when we're asked to find the coefficient of x raised to the 0 power, you have to take into account both terms because they are going to have an effect on like what the degree of your term is going to be. Okay, so I'm going to kind of do a little bit of work here on the side so we can keep track of this. So we know the first term is going to be 9 taken 0 at a time. I'm not going to write out the 9 taken 0 at a time. I'm going to add that in like at the very end. But what I do want to look at is like what the other factors are going to be for each term. So if we look at the term 9 taken 0 at a time, x is going to be raised to the 9 power, and then negative 1 over x is going to be raised to the 0 power. And we see that like when I multiply those two things together, we get x raised to the 9th power because negative 1 over x squared, my apologies, that should be negative 1 over x squared. So negative 1 over x squared raised to the 0 power, that's just going to be equal to 1. Okay, so that's going to make the coefficient, or it's going to make that term be x to the 9th power. Okay, let's see what happens when we drop the exponent of the first factor by 1 and raise the exponent of the second factor by 1. Okay, so that'll be 9 taken 1 at a time of x to the 8th power, and then 1 over x, negative 1 over x squared raised to the first power. So when you multiply those two things together, you get x to the 8th times negative 1 over x squared. So that's going to become negative x to the 6th power. Again, not the like degree that we are looking for. We're looking for x raised to the 0 power. So let's go ahead and change the exponents again. Okay, so the next term would be 9 taken 2 at a time of x to the 7th power times negative 1 over x squared raised to the 2nd power. So if I were to multiply those things together, you would get x to the 7th times negative 1 over x squared squared is going to be 1 over x to the 4th, which means that that term is going to become x cubed. So it's still not the x to the 0 power term that we're looking for, but we're getting closer and closer to it. Okay, so let's move on to the next one. So the next term would be 9 taken 3 at a time of x raised to the 6th power. So x raised to the 6th power times negative 1 over x squared cubed. So if I were to multiply those things together, we would get x to the 6th times negative 1 over x squared cubed. That's going to become negative 1 over x to the 6th, which is negative x to the 6th power. And we get that to be negative x raised to the 0 power. So that is my x to the 0 power term. Okay, so all we want to do here is we want to find the coefficient of that term. So we said again that term is going to be 9 taken 3 at a time of x raised to the 6th power. Again, the exponent for x is going to be the difference of 9 and 3. So 9 minus 3 gives us that exponent of 6. And then the exponent for the next factor is going to be the number on bottom, which is 3. Okay, so we just want to find the coefficient of that term. Okay, so 9 taken 3 at a time is going to be 9 factorial over 3 factorial times 9 minus 3 factorial, which is 6 factorial. And then we have x to the 6th power times negative 1 over x squared raised to the third power. So that's negative 1 to the third power, which is negative 1, over x squared to the third power. When you have a power raised to a power, you multiply the exponents. Okay, so we just want to go through and simplify here. So I can rewrite that numerator 9 factorial as 9 times 8 times 7 times 6 factorial over 3 times 2 times 1 times 6 factorial. So those 6 factorials cancel. 3 goes into 9 3 times. 2 goes into 8 4 times. And then you have 3 times 4, which is 12, times 7, that's going to be 84. And then you have x to the 6th power times negative 1 over x to the 6th power. So when you multiply all those things together, you get negative 84 times x raised to the 0 power. So the coefficient of that term is negative 84. Okay, so it's the same idea as the last two examples that we worked in class, but this time you have to pay attention to both terms to figure out the coefficient of x raised to the 0 power, because both terms have a factor of x in them. And we have the same idea with this example as well. All right, so directions here ask you to find the coefficient of x squared in the expansion of rad x plus 3 over rad x raised to the 8th power. Okay, so I want you guys to pause the video and work that one out on your own. And then we'll talk about it together. Okay, so let's take a look at this one. So let's just kind of go term by term here. All right, so the first term is going to be 8 taken 0 at a time. Make sure you have an eraser accessible, because we're going to be erasing some stuff here. Okay, so it's 8 taken 0 at a time of rad x raised to the 8th power, and then 3 over rad x raised to the 0 power. And again, like, I have to utilize both terms here because both terms have a factor of x in them. Okay, so if we were to like multiply out these two things, you would get rad x to the 8th power, which is x to the 4th power. And then 3 over rad x to the 0 power is just 1. So we don't get the coefficient of x squared like we were hoping for. So let's move on to the next term. Okay, so the next term here would be 8 taken 1 at a time of, rad x raised to the 7th power over 3 over rad x raised to the 1st power. Okay, so rad x to the 7th power is going to wind up becoming x cubed rad x, because you can separate rad x to the 7th as rad x to the 6th power times rad x. And rad x to the 6th power is going to be x cubed. Okay, and then 3 over rad x to the 1st power is going to be 3 divided by rad x. So when I multiply those two things, the rad x's cancel, and we get our term to be the x cubed term. Okay, which is still not what we're looking for, but we're getting closer. All right, so let's see what the next term is going to look like. So that's going to be 8 taken 2 at a time of rad x to the 6th power times 3 over rad x raised to the 2nd power. Okay, so rad x to the 6th power, that's going to wind up becoming x cubed. And then 3 over rad x quantity squared, that's going to be 3 squared, which is 9, over rad x squared, which is x. And then when I multiply that together, we are going to get the coefficient or we're going to get the x squared term there because we're taking x cubed divided by x, which is the x squared term. Okay, so all I want to do now to finish figuring out the coefficient is we have to figure out what this is, 8 taken 2 at a time. Okay, so that's going to become 8 factorial over 2 factorial, excuse me, times 8 minus 2, which is 6 factorial. Okay, so to clean this up, 8 factorial is going to be 8 times 7 times 6 factorial over 2 times 1 times 6 factorial. Okay, so the 6 factorials cancel. We get 2 is going to go into 8 4 times. So 4 times 7, that's going to be 28 times x cubed times 9 over x. So the x's cancel. 28 times 9 is going to wind up becoming 252. And then we have this factor of x squared left over. Okay, so the coefficient of that term is going to wind up becoming 252. Okay, so you guys will definitely see, like on your test when you take it, you're going to have some questions similar to like these examples up here, numbers 1 through 3, where you have to expand out a binomial. And then you'll have some questions similar to the last 4 examples as well, where you need to pick out specific coefficients or specific terms in a binomial expansion. Okay, so, and you guys will have homework questions similar to this as well. All right, so that's it. That wraps up this section, guys. Make sure you get your homework assignment done. Don't forget about your quiz on Monday, and we'll see you guys in class on Monday. Okay, hope you have a great weekend. Take care, everybody. Bye-bye.